So this is C++ Programming 3. This is the last of the trio that you guys are going to be having. This is going to cover, just in general, this class is going to cover two major things. One is going to be learning how to do object-oriented programming. What that means, like to you, what practically that means is that you guys are going to be able to write more complicated programs with less code, and you're going to be able to do it faster. And it's kind of like I'm going to be teaching you guys how to make things that are reusable over and over again. And in that context, we are going to be talking about object-oriented programming in the context of making an asteroids clone. So we're going to be making an asteroids clone from scratch. This is a top-down shooter. This is kind of one of those deceiving things where Asteroids seems like a pretty simple game. I don't know how many of you guys have actually seen Asteroids. Is anyone here not familiar with Asteroids as a game? Okay. It's a top-down game. You blow up asteroids. The thing that's kind of deceiving about it is that you have the first case of having dynamic objects that are created and destroyed as you're playing the game. And you have multiple objects. You have 3, 6, 12 asteroids flying around at any one time. So you're going to have to learn how to manage those objects. Before in Pong, we always had a limited set of objects. Some of you guys were trying to do stuff in the finals for like creating objects during the game. I'm going to show you guys how to do that stuff really simply so you can have objects that are spawned in. Things like bullets are another good example. You guys will be making bullets. Like, I'm going to show you guys how to make bullets that you can have as many on the screen as you can. And trying to do that in the scope of what we were doing with Pong was too much. But now, with object-oriented programming, we can do a lot more powerful things with much less code. So here are the main things that we're going to be covering. I added 2 more things on the bottom. These are like, I'm going to spend one class period talking about these 2 things. But first, let's start with object-oriented programming. Mostly, there's like 3 parts of object-oriented programming we're going to cover, working with things called classes. These are a lot like structures. They're just a way to group variables together and then reuse those variables over and over again. Objects, which are representations of classes during the game while it's running. So you're going to take a class, which represents a blueprint for a series of for pieces of data, things like a ship or a bullet, and you're going to make those things in game. So you're going to take this class, which represents a bullet. You're going to make like 100 of them while you're shooting, right? Which also deals with dynamic memory. So I'm going to be showing you guys how you're going to be actually able to get memory for those bullets and then return that memory back when you're done with it. This is kind of going to develop more. This kind of is the part of C++. That's the plus part of it. This is going to be teaching you guys a little bit more about thinking at a higher level about your game too. Previously, we've been kind of doing everything in one giant main function or like a few smaller functions. However, in this case here, I want you guys to take a step back and think about games from a more abstract point of view and not just be so caught up in the actual specifics of writing lines of code, but more like, let's think about how we're going to organize our code as opposed to just starting to write it. This gets really important when you want to make anything more complicated than Pong. Even a game like Breakout or Tetris, you need to think about things at a higher level just so you understand how to organize that stuff. So when you're writing the program, you're not like hitting bugs all the time. There are ways to approach writing games that reduce the amount of bugs that you ultimately write, just as a side effect, which is a really nice way to organize it. Because you spend less time like with your code not working and more time actually developing the game. Asteroids itself has a few unique challenges that we're going to also encounter. It is 2D gameplay, so it's similar to Pong. It's top-down. It's not going to be 3D. However, there is the concept of game state management. So you're going to have the concept of, hey, I haven't started the game yet, or the player is invulnerable during this period of time, or the round has restarted and now I have more asteroids to blow up, and managing going from one state to another without basically putting a bunch of if statements in your code, or like having those things pollute the other states. Having those states which are like, hey, the player is invulnerable, be a distinct section of code that's separate from all the other game state that you have. So we're going to talk about how to manage game state. This is think like a fighting game, for instance, like a Street Fighter V or something like that. Like there are many states to that game where like you're picking your hero, you're picking your fighters on each side, you're seeing the versus screen. There's like an intro sequence for each hero. There's the actual fighting part. There's like the slow-mo that happens when you kill someone or beat someone. And then there's like the next round that starts. All that stuff, that state management, are important parts of games, unless you have a game that's literally just one state. We're going to do more 2D game physics too. So we're going to be handling like acceleration and velocity more again this quarter. And we're going to be talking about how to do things like orient bullets that you want to fire. We did a little bit of this when we were doing some of the labs last quarter, where we were launching like the ball, like you hold down spacebar and you launch the ball at an angle. Now we're going to basically treat that ball like it was a bullet, and we're going to let you rotate the ship around to shoot it anywhere. Okay, so you're going to have a little bit more practice doing 2D vector math, and a little bit of game design too. I do want you guys to think about how you can incorporate different types of gameplay into asteroids, as well as iterating on your game. Bless you.
Thank you.
Iterating on your game, meaning that you're going to be playing your game a lot. We're going to be making asteroids from week 4 on, so we're going to be trying to play more and more of asteroids as we develop it. Okay, so the last 2 things are kind of tertiary goals. These are things that I'd like to cover just because I think they're important. These are very common to use. Source control is a term that's used. It's basically managing your files for your program. I'm not going to say in the cloud because it doesn't necessarily mean it's on the cloud, but basically it's a way for multiple people to collaborate on the same project at the same time. If me and Anthony are working on the same file, like we have the same main.cpp that we're working on, we take it home and we're working on it at home because it's a group project. Then we come into school, how do we take the work that Anthony did and the work that I did and coordinate them and merge them together, right? And that problem exists at a really big level too for something like Overwatch, because Overwatch has tens of thousands of files that people are working on. A lot of times people are working on files at the same time. This also applies to things like assets where you have like a texture. Only one person can really work on a texture at a time, right? Like you can't have multiple people working on a texture, or like a music. Let's say someone's composing a song. You can't have multiple people composing it. So how do you make sure that there's no conflicts between people? So source control basically enforces a concept of checking out a file, and also lets you exclusively check out a file, which means that you can check out a file and prevent other people from working on that file. And when you're ready, you can check in that file, and then that file is available for other people to grab no matter where they are. In fact, source control also maintains a history. So it's a lot like Dropbox in a way that you can synchronize files. However, source control maintains all the revisions that have changed for that file over the entire lifetime of that project. So let's say you screw something up severely. You checked in something on your first day of the job and you broke the game. Like you did something really bad. Let's say that you like accidentally deleted half the files, and oh shit, I checked that in because you just weren't paying attention, and and like half the game was just like deleted, right? Because and then people are grabbing it and downloading it and be like, where are all these files? Source control maintains a history, so all you have to do is just go backwards one revision before your check-in, and then you can undo that deletion and then re-upload the correct version, which has all the files intact. Source control lets you have safety. They can be backed up. So our Perforce repository, which is the name of our source control software, is backed up on a weekly basis, so that we don't have to worry about like our hardware dying and then losing all of our work, right? So what I'd like to do is, this is going to be the last week of class, is I'm going to have you guys check in your asteroids project into Perforce, and I'm going to go over a little bit of a tutorial on how to use it. Most of the time, you learn how to use this on the job. Like you get to your first day or a week on the job, and you like are given like your Perforce login, and you're expected to kind of start working with it. It's not that hard. It's pretty simple to use. It's conceptually it's easy to understand. It's just a way to store and manage your files. However, I do think it's having a little bit of exposure to it is important. Plus, there's different kinds of source control that's available, and each one's a little bit different. There's Perforce and Git and SVN and CVS. There's source control that's used for like artists called Alienware or Alien Brain. We have our own source control system that we wrote for Overwatch for our assets, and we use Perforce. Some studios use multiple types at the same time. So we're going to learn how to use that. Unity as well. So I haven't given you guys a lot of exposure into 3D game engines. That was deliberate because I want you guys to be focusing on C++. However, I do think a little bit of exposure into Unity will be helpful to you. So in the last week of class, I'm going to be showing you guys how you can take what you've been learning in object-oriented programming, because Unity is pretty heavily object-oriented, C# just in general is, and apply it to working in the 3D game engine. I feel like Unity is very, very easy to use. I can give you guys a 45-minute to an hour tutorial, and you guys will know enough to kind of get started and get going. And you guys can start making games in Unity really quickly, okay, given your knowledge of C++. So yeah, we'll be doing that last week. Any questions? about all that stuff. I know I talked a lot, and there's a lot of stuff to go over. But those are the goals for this course. So these are the chapters that are relevant to our class, 10, 11, 13, and 14 in the Primer Plus. These talk about object-oriented programming principles, classes, how to deal with overriding functions, virtual functions, polymorphism, all these things that we're going to be talking about in class. However, if you are so inclined to read more about this, you can. This is the same book we've been using, it just happens to be different chapters in the book. I believe chapter 12 is a section, I want to say it's on memory management. Let me just double check here. I'm not saying you guys can't read it, but I want to say that was a chapter that was not, dynamic memory allocation is where it was at. So we are going to be talking a little bit about dynamic memory allocation. However, as far as games are concerned here, how this is going to be used is going to be very specific. So the entire chapter is an interesting read. I encourage you guys to read the entire book if you guys are serious about programming or learning how to program. Chapter 12 you can probably leave out for this course. So the requisite project and tools that you guys need to know about. So Visual Studio 2015, and we're going to be using SFML again, and then the last week is going to be Unity and Perforce. Okay. Class structure is going to be mostly the same as last quarter. It's going to be lecture and in-class practice and labs. You guys are going to have a lot of homework and final projects. The final project is pretty much going to be the same idea as the last quarter. You're going to be given a twist on asteroids. Give you guys a modification to asteroids that you can make. And then we'll be handing that in at the last week. Questions about the structure. This should be pretty familiar to you guys, how we're going to be doing it. We're not going to be drastically changing it, however, we are going to be drastically changing what we're learning. This is going to be the general structure of the class, week per week. So weeks 2 and 3 are going to be a little different. I'm going to be moving those to incorporate those into the asteroids course lecture. So next week we would have started doing object-oriented programming. This week, specifically, I'm going to be having you guys try to remember what you forgot. I'm sure there will be some things in programming that you did not quite remember, so hopefully I'll be able to help you with that. And then jumping straight into OOP, which stands for Object-Oriented Programming. And then weeks 4, which is pretty much when I get back on week 4, we're going to start right away into asteroids. So I'm going to incorporate the OOP stuff that from week 2 that we aren't going to be going over into week 4 and 10 through 10. And then weeks 10 and 11, the last 2 weeks of class, I'm going over source control, integration, and Unity. Questions about this? Pretty straightforward, right? Grade structure. So half your grade is based on homework, 30% of your grade is based on attendance, and then the last 20% of your grade is the final project. So as long as you are here and doing your homework, you will be guaranteed a B. That is it. Okay. Web and software tools. There should be, if you haven't found me on YouTube yet, you can find me on YouTube. You can either type Karam197, you can literally Google my name in YouTube and you'll find me as well. This is contact info. Hopefully you guys have my contact info by now. If you don't already, there it is. You can text me or email me if you need me. Questions? Any other questions? Okay. All right, let's get into the review. I'll give you guys a break after I go over this, and then I'll give you guys a lab, and you can do the lab. Okay? I just want to give you guys a quick overview, kind of like the whirlwind tour of what we did last quarter, so I can talk about it, so you guys can refresh your brain about what we did. We spent a lot of time talking about functions, and functions are still very important. If you're still not comfortable writing functions, this is way past the time to be lecturing on it, so I really recommend you guys to try to use them as much as possible. Functions are really powerful. They let you reduce the amount of work that you do, which is always important for someone that's lazy, which a lot of people are, including me. I don't like writing I don't like repeating myself a lot, so I write functions quite often to help reduce the amount of duplication I have to do. Functions are basically, you have a contract to write for functions, you have a prototype and a function definition as it states here in the slide. And the key things is that for every single function that you have a return type, you have a name, and you have a series of arguments. And when you define your prototype with the semicolon, and when you're declaring your implementation, It looks exactly like the prototype. However, inside a set of curly braces, you have the actual statements that you want to execute. Calling functions are rather simple. You just call the name of the function, and you, in parentheses, you pass it to arguments that you need. Okay. All right. Spend some time doing that. Pointers. So we had some experience working as pointers. It's not something that I really expect you guys to fully grok. Like I don't think that you guys have the experience yet to fully understand them in all the context. However, I do expect that you understand how to distinguish pointers from other things and what differences you need to implement when you're actually dealing with pointers in your code. Okay, pointers themselves, what they store is memory addresses, right? I kind of tried to hammer this home. A pointer is just a variable that can only store memory addresses. That's it. It literally stores a memory address. And it doesn't store any data, it just stores memory addresses. So it stores the address of some other data somewhere. And you can get at that data through various means, and there's a variety of operators that you can use to deal with pointers. Pointers themselves are pretty ubiquitous in game development. Like, this is not something that is a unique concept. They're pretty much used everywhere, like all the time. So this is not something that is a ignorable part of C++. This is just kind of part of C++ and C development. A lot of languages don't deal with pointers. C# and Java in particular don't deal with pointers. Like C# kind of hides this functionality from you. However, C++ is meant to be it's meant to be originally like a systems programming language. However, it's great for game development because pointers give you control over memory access, which is important when you want to run 60 FPS or higher on console. Okay. Arrays. Arrays are a way to represent a variable and say that you want to have multiple slots for storing that variable. You can have one variable represent multiple slots for data. And so when you have an array, you specify the size of the array. In this case, I have 5 slots. And when you're accessing arrays with the square brackets, you have access to them via indices, right? This is a pretty straightforward concept. What we're going to be learning this quarter is going to be learning about dynamic arrays. So far, we've been mostly dealing with what are called static arrays, meaning that you have to know the size ahead of time. It means you have to know you want exactly 5 things. However, oftentimes you don't know that you want exactly 5 things. In a game like Asteroids, you don't actually know how many bullets you're going to need room for. You are going to need an array of those things. However, we're going to need to dynamically allocate them. This means that there are some built-in structures in the C++ that we can use that helps us have as much room as we need to for these bullets. So we're going to be learning more about arrays this quarter, but in the context of Asteroids. Yeah. SFML. Just to reiterate, there are differences in SFML. We've dealt with a lot of SFML with loading files off disk. If you think about all the things that you've loaded off disk, from textures to music to sound, all those things are represented as files. So SFML has a way to deal with those images. You can also draw raw shapes and input. Input is the big thing. I want to make sure that we are going to be spending more time with input. Remember, there are 2 ways to deal with input in SFML. There is the, hey, Windows, tell me when someone presses a button. And then there's the, hey, let me go ahead and ask Windows if a button is pressed or not. Those are 2 different ways. One is an event-based system, and the other is a polling-based system. And SFML lets you handle things in both ways. If you were to handle input via an event, you get those events when Windows tells you when those things happen. However, if you really need to know if the player is pressing a key right now, you need to ask Windows about that. And that's the difference when you want to handle things like movement and you want to see if, hey, as long as he's pressing the W key, I want to move him forward, you need to be asking Windows every frame if the W key is pressed. If you're waiting for Windows to tell you that W key is pressed, they're only going to tell you periodically. They're not going to tell you every frame of your game. But if you want to know the exact frame that they pressed the key or the exact frame they released a key, that's more when you want to have Windows tell you when those events are fired. Okay. Those differences between events are really important. And we dealt with that a lot, like for knowing when you pressed a key versus whether you're holding a key. Okay. Sound effects. This is another big part of SFML. So there is a difference between sound effects and music. common problem that people were running into was that you'd be restarting the same music file over and over again, or you'd be playing the same music every frame, which would mean that you wouldn't hear it. However, keep in mind that I am going to be expecting you guys to be doing SFX and music this quarter as well. All right. So I'm going to be giving you guys a little bit of a softball lab today. Yeah.
Is
a softball pitch.
On the underhand?
Yes, kind of, basically. The reason why I say that is that you guys have kind of done this before already, some of these. So I'm giving you guys, there's a lab here in Zool, and there are 5 small programs I want you to write. Each one of these in a separate CTP file. These are going to kind of try to jog your memory for how to use if statements, switch statements, functions. So the first one is going to be writing a program to let you enter a grade and then modifying the score. So here's the thing about these problems. I expect you to have all the ones that are non-bolded done. So it means that for number 1, you have to do letter A. Okay? However, if you feel like you're getting through them pretty quickly, or feel pretty comfortable with them, and you're looking for something more to do, or you finished all the labs already, then you can go back and do all the ones that are bolded. The ones that are bolded are a little bit trickier. They're like a little bit more, they're enhancements on the existing program. Okay, so they're a little bit more involved. But I expect everyone here to be able to do everything here that's not bolded. Okay, which means that it's going to be 1A and it's going to be 2A and 2B. It's going to be 3A. Write a program that asks the user to enter any number other than 5 until the user enters the number 5. And then the other ones you can read. I'll go over them in just a second. Number 4 is write a program that asks the user to enter the number of hours of video game played over summer break by 10 different people. Once the data has been entered, the program must analyze the data and output which person played the most video games over the break. B is modify the program so it also outputs which person played the least number of video games over the break. All of these are optional. This star one, this one here is kind of special. This one and 5E. These are a little bit more tricky than the other bolded ones. So these are like, I guess if I had to put 2 stars next to them, I'd probably put 2 stars next to them. You can pick to choose them to do them or not. They are just a little bit more tricky than the others. Write a program that calculates a random number from 1 to 100, and the program that asks the user to guess the number. Okay, and I think you guys did this for one of the labs. The last optional part is make it so that the program, so that no matter what number the user thinks of, the computer will guess it for you in 7 guesses or less. Doesn't matter what number it is.
I remember that one.
Yep. So you guys can do that one too. Okay, but I had you guys do that as a homework. I'm expecting you guys to do all these things in lab today in class. Okay. Anything you don't get done is part of homework. However, I do have a homework assignment for you as well. Okay.
So generous.
Thank you. I think there's an open house today, right?
There's a concert.
Yeah, there's a concert too. Okay.
$30.
So if you guys have any questions on lab, I'm going to be walking around and trying to see if you guys have any problems with these, but these are not using SFML. The homework I do have in Zool for you will be using SFML, so I will put a version of the engine on Zool for you.
It's already there.
Okay. Yeah, there it is. And the homework is another kind of review homework. So I just have 6 things I want you to do. And it all has to deal with circles and interactions with the circle and the mouse. So these things you can do for homework. However, if you get done with your lab, you can do it in class, obviously. So, cool. All right, so for the rest of the class here, I want you guys to do a lab and review, and I'll be running around and trying to help you guys as we find time for it.